slides to go, so that's the ambition. Okay, why lake restoration into an international context? Well, we are working 40 years on lake restoration, but we did it in phases. And most countries where we come today, they have to do complete lake restoration. That's their ambition within a couple of months or a couple of years. And I will show you some examples, but first I will start with introduction of my company. Witteveen+Bos. My name is Marten van der Wijk. I'm head of the soil remediation department. Amongst others, we do sedimentary remediation. Witteveen+Bos is an employee-owned consultancy firm, and they cover all areas of engineering. Looking to the environmental sector, it's about air, soil and water, and we do all types of investigations and designing jobs. Looking to my group, risk-based land management, we have expertise on waste dumps, landfills, brownfield redevelopment, remediation, the pesticides and also mining sites. Okay, why Witteveen+Bos and lake restoration? Well, we have a long track record on dredging. I know that in your delta area there's also a long track record on dredging. We have the track record on water treatment, management of the aquatic system and sediment remediation. And yeah, we have improved the situation with our environment, but the second picture from above is showing how our waters were looking 30 or 40 years ago. So we came far, but it's still a young profession. Why we have some added value, we think, because of our delta technology, the environmental engineering of 30 years experience, systematic and integrated approach of problems, and also the sustainability.
Well, the content. First I will tell you something about the development of the different types of activities in the Netherlands along the last 40 years and for dredging even longer. Also show some examples of lake restorations. And then we go to the international context. And in the end I hope we can reach some conclusions. And if you can see, yeah, we are already doing dredging also for 2000 years, because we are living in a delta and without dredging we can't survive. We need open channels, we need canals to convey our boats. Well, if you're looking to dredging in the Netherlands, we started with land reclamation, capital investments, new waterways, new docks, and we have to maintain our infrastructure. But only since 1980 we started to apply dredging techniques for environmental projects. Before it was simply dredging and not any focus on environment. Well, if you're looking to dredging in the Netherlands, nowadays I think a lot of countries in the world know us about our large-scale land reclamation. So if we focus on top, you can see Dubai, project in Dubai, large harbor investments, big seafaring boats. But we have also inland waterway dredging equipment. And we have different types of equipment for small-scale waters, medium-scale waters, and we have adequate equipment for that. Looking to the water treatment, well, we started to look seriously into water treatment since 1970, because then we got a water law. But looking at the situation before 1880, before 1880, we have uncontrolled discharge of sewage within the cities. Then we started to collect and dispose it out of the boundaries of the city. Since 1900, we started with simple treatment techniques. But all those techniques still needed the self-cleaning capacity of the receiving surface waters. So we had not a complete treatment, there was only a sedimentation and some oxidation, but the large part of the treatment was still in the receiving surface water, so we had bad quality. Well, in 1970 something changed. Public opposition against the bad water quality and also the rapid development of the economy caused us to develop a law on water pollution, to prevent water pollution. Since then, we have indeed fast, rapid development in new treatment technologies, and also we invested a lot in those treatment facilities and collection systems. And we became more ambitious. So we had new techniques, new tertiary techniques to clean the water from the nutrients. We looked at the energy efficiency and also how we collect and manage our collection systems. Well, then looking at the management of our aquatic systems. Well, what I mean with management is how our aquatic surface water are functioning. And I think the big drive forwards was there, the development of the European Water Framework Directive, where we set qualitative and quantitative status goals for the status of the water bodies. And now we have to look to more than only effluent qualities. For example, we have to look at the biological quality of the surface water, the hydromorphological quality, physical chemical status, chemical quality of the specific pollutants. And we have to set objectives for every individual river basin. And in the Netherlands we have high ambitions. Well, when you summarize it, till 1970 we depended on the self-cleaning capacity of the receiving surface water bodies. Then from 1970 till about 2005, we just wanted to have the effluent quality of the water treatment should be more or less comparable with the receiving surface waters. And now we have even higher ambitions, so we have to increase our efficiency of water treatment. But saying this, and when we have objectives for the functioning of the water, we have to really understand how the water system is functioning. An integrated approach for which we need a lot of data. But with this data we can also do computer modeling to predict what future water quality will be. And yes, sediments are part of the equation. So you can't simply say we have collection of sewage water, we have treatment of sewage water, but you have also to look how is the sediments taking part in the equation and what is the influence of sediment quality on the surface water quality. Here, for example, you can see what the nutrient load means for the turbidity of the water. If you don't have a lot of nutrients, you have clear water. But if you have a lot of nutrients, it will not be that clear anymore. And of course, if you have nutrients in the sediments, they will be released to the water column, and you have this effect. Well, in 1980 we had the first case of soil pollution and soil remediation in the Netherlands, and afterwards we got the soil law, the law on soil pollution. That means also that we started with remediation of hotspots, really hotspots where a lot of pollution was present in the sediments. Initially we did a lot of research in the development of multiple treatment techniques, but finally we came on more, the focus became more on off-site disposal, soil washing, solidification, sand separation, and maybe on-site containment. And then we had also to take into account that with the traditional dredging projects, we have also to take into account what type of sediment is coming out. So it's not only a hotspot solution, a hotspot remediation anymore, but all sediments coming free from dredging in the Netherlands are integrated and governed under the law of soil. And since 2000 we are having more ambitious about the function of the surface water. Now we have also sometimes to dredge, not because there's a hotspot pollution, but there's a lot of nutrients into the sediments. Well, to conclude, we have in the Netherlands developed an integrated approach for lake restoration in the last 4 decades. In several steps, essential new techniques were added to the available toolbox for leak restoration. Our approach is supported by research efforts and a set of appropriate policies, very important. The development of a clear legal framework and its enforcement were essential preconditions for this approach. And now I show you first some examples in the Netherlands. Well, looking to water treatment, then we have to say, with all those new techniques developed in the last 4 decades, we have the ability to come up with appropriate techniques of energy efficient wastewater treatments, plants, but we can also go to recycling of processed water or the production of ultra-pure water. In the Netherlands we produce ultra-pure water from effluent from wastewater treatment. So in essence, the techniques are available to get good quality effluent water. But still we have to think about more than this when we start talking about lake remediation. We have also to look at the old source areas. For example, if we had before farmer sewage farms, they can still lead to the lakes and to the surface waters. So we have also to take into account what are the effects of those old sources of pollution and how we have to remediate them or to manage them. Okay, when we are looking to surface water quality, we have also to look to ecology. What type of ecology is present at the moment, and what type of ecology will be present in the future. And this requires a different type of water quality. There's an interrelation. We have also to look to river management, for example. How are quantities and qualities of water passing through the rivers? Here you can see an example how we made a new lake. We had to take into account that nutrients were present there from the past. Now coming to the river mouth of the IJssel. Here we have a large lake, which was the mouth of one of our delta rivers. The lake was completely loaded with nutrients and also some pollution. And what we did, we dredged the lake, but we also we integrated flood protection and sustainable shipping approaches within this technique, and we developed here some new islands for new nature areas. Where we stored the sediments, in this ring there's a big disposal facility, controlled disposal facility, and there we can store large quantities off-site disposal of sediments, and afterwards we will cap it and it will be a new island. Of course, also the environmental dredging. Some sediments are polluted and have high levels of pollution. For example, here heavy metals. It's simply by digging, transport them to this disposal facility. We can also look to a more integrated approach. Here you have an old sewage treatment system, an old sewage farm for the effluents, and then it went into the water system. And here in this project we constructed a new wastewater treatment plant. We developed, we remediated the sewage farm and the lakes, the sediments from the lakes and the river. And in the end we had also some new development of nature. So a completely integrated approach for this project. In the Volgenmeerpolder it was a heavily contaminated wetland. Large parts were covered by water and also really wetlands. And here we had a situation that it was too worse to restore, and then we came up with a new solution, a new idea. Here you can see how it was before we started the works. And this should be again a nature park with clean surface water, so this is really a challenging job. What we did, we made a plastic foil on top, a plastic liner, and on top of the liners we had new ponds of water. Here you can see execution of the works. The plastic liners installed, new ponds, the outer contours of the new ponds, and then in the end, on top of the old landfill, we made a new area of small lakes. Well, if you look into the international projects, again, it starts always with data gathering and understanding what's going on. So I will first show you some inventory and prioritization projects, and later on I will go in deeper detail into projects. As said, the Water Framework Directive in Europe is a very important driver. And here you can see a project where we did an inventory and drafted a river basin management plan for a river basin in Romania. But then, if you're looking at the scale of a river basin, you have also to take into account all the sources. And one of the sources can be, for example, a mining area. And in the next slide, you will see what what type of water can come free from a mining area. So it is clear if you want to remediate the lake, you have also to control the inflow from such areas. And also, if you're looking at the river basin, at least you should know which sources are there and how you can take them into account when drafting a management plan and remedial strategy for a lake or a river system. Here we have such a project in Serbia. And also in Albania we did a hotspot assessment for 27 sites, different types of sites, but assessing how they can affect this water system. Sometimes it is simply sampling of the sediments, like here in Kazakhstan, and this was for an industrial base. But if you're looking to the more complex situations, which we are coming across now more and more, is that we have only a limited amount of years, not 40 years to develop something, but in 3 years they want to have a clean water system, including a clean lake. This is an example in India. Here we have an industrial area, here we have a lake, and this is the irrigation area. And the color of the lake, you can already see it is called the pink lake, and that's because of the pollution originating from this area. So if we want to address here the quality of the lake and the sediments, then we have also to address some issues here in the industrial area. Otherwise it doesn't have any sense. It doesn't make any sense. And also in this area, of course, there will be a lot of wastewater produced, so at least there should be some wastewater treatment there. Well, in this investigation we showed clearly that there was a link between the industrial area and the pollution in the lake, and that we have to do more than only taking account of the historical links. But we have also to take into account the present links, like the sewage quality of the sewage water, the surface water runoff, and also, well, maybe the groundwater connections. So you have to look at more than only the lake in this case. Here you can see it. Here's the source. There's also some outflow on the premises of the industries. Sewage and industrial sewage here, industrial wastewater, resulting in accumulating of pollution here, and in the end coming up in the lake. And here you can see dyes, pink dyes from the textile industry, which were discharged in the lake. Well, if you want to address such a problem, or let's say a problem, then we have to make an area-wide approach. It's not simply making a remediation or dredging plan for the sediments, but you have to make an area-wide approach. And then you look at the industrial area, what you can do there, what you can do in NMK, in the lake, and also what is going down in the plains downstream, where the irrigation is taking part. Here we had the ambition that the water coming from the lake should be fitting again for agriculture. Well, we had 32,000 cubic meters of black sediments in the lake, and then we have also, of course, to think about how we are going to remove the sediments from the lake and how to treat them. And I will show you later on some slides of what we did. We have also to think about wastewater treatment in the future, which can sustain the objectives of this project. And in this case, we couldn't take away all the polluted material from the lake, but also to cover some of the material, because otherwise the impermeable clay layer would disappear and we wouldn't have a lake anymore. So we have to think about dredging techniques. Can we excavate it in the dry conditions, removing the water from the lake, or we have to apply dredging equipment? How to dewater? Do we dewater in like in a traditional lagoon, or do we dewatering with, for example, geotubes? And if you do, you select a technique, you have to do the feasibility testing as we discussed this morning. And here you can see examples of feasibility testing, and taking into account that it was the original material containing 10,000 to 15,000 milligrams of oil and also a lot of dyes. And this was the process water coming out of the geotubes after dewatering. I think this shows already that that was a good potential measurement technique. And then, of course, again, what is the end situation? If you contain sediments in a geotube, what is the quality of the material contained in the geotube? What is the quality of the process water? and what is the quality of the leachability testing. And in this case, we could prove that 99.5% of all pollution was contained within the tubes. But what will happen in the future? So we have to take it into account. And where also to apply the tubes. It could be far away from the lake or just near the lake. And then the in-situ capping. If you can't remove all the polluted material, maybe you have to take measures to cover this polluted material which is left there with a new layer of sand, maybe mixed with carbon and active carbon. And maybe it is also necessary because there's a lot of nutrients available in this layer which can otherwise go to the water column. So, integrated approach. Then the other project where we are currently working on is in Baku, Azerbaijan, where 9 lakes are encircling Baku city. And the city was before, it was like this, but it is expanding towards the lakes. And now people want clean lakes because they are part of these urban areas, are becoming part of their urban areas. Baku has a well-known reputation as an oil city, so a lot of oil fields, and because of the rapid growing city, also a lot of uncontrolled discharge of sewage water, threatening the quality of the lake, and indeed some of the lakes are more or less dead. In the last few months, we did a lot of investigations in 3 months. So all the types of investigations we did for our lakes in 40 years, we did here in 6 months, a lot of data gathering, and from this data we could make a good analysis, and I will show you some results. Well, if you look into the ecological function of a lake, there you have different key factors: toxicity, organic loads, nutrient loads, transparency, nutrient release from the sediments, habitat stability, dispersal, physical disturbance, experience of natural beauty. And to assess this, you need a lot of data again, and different types of data. And I will show you some results of the outcomes now. If you're looking, for example, to the toxic conditions of the chemicals, then for these 9 lakes, 4 of the lakes were more or less completely polluted and no life anymore. Oxygen levels. In 5 of the 9 lakes, oxygen levels were too low. Transparency. All lakes have a problem with transparency. And of course this is again related to the nutrient load, one of the factors. So we have to take also to assess what is the nutrient load. What is the input from uncontrolled sewage systems? How are the borderlines? Do we have opportunities to construct shelter places for plants and animals? And also, in this case, there was still ongoing disturbance of lake shores with construction and dumping. Well, combining all those things together, you can make an assessment. And the green circles are more or less positive, and all the red circles are negative. And from a scheme like this, you can already make an integral assessment what is required for the lake. And then you can maybe working on a few principal statements. In this case, we said, okay, all projects should add value to the location, to the lake, to Baku and Azerbaijan. So it's not only about the lake, it's about the context of the lake and also the shorelines around the lake. We also said, in a complex situation like this, where you have a lot of pollution, the first thing is create a standstill. So stop uncontrolled inflow of wastewaters, stop uncontrolled dumping of pollution and wastes. Then think about how to restore value, make the lake healthy. And if possible, we should add new developments and add real new value, bring the potential of the lake to life. And sometimes, and we had a few lakes in this example, there is a situation, like up the Volgemeer in the Netherlands, where the situation is that worse that we should create new surroundings. So we have to cope with the legacies of the past and come up with a new solution. And I will show you how we did it for 3 lakes. Here you see the principles of these statements again. Well, we assess the potential of the lakes, and every lake, now you can see 9 lakes, more or less a uniform surrounding, but every lake has its own specific problems and opportunities. And how we come to these opportunities and problems, it's about the data again. But this implies also that every lake has its unique solution. You can see it in a different way, and the green boxes represent the solution which was selected. And you can see in 3 lakes we had to start over again. So the pollution was too heavy to solve with the traditional way of dredging and wastewater treatment. Well, we have to take into account that Baku is a growing city. So every strategic planning we are doing and every remedial planning we are doing, we have to take into account the objectives and the aims of the city planning for 2030. Well, to show you, every lake has its own solution. For Koashan Lake, for example, we said, okay, stop dumping, no additional discharge, and then we can start with cleanup and basic water treatment. And then already we can arrive to a better water quality which is fitting for campus sports and urban life. And here you can see a sample. This is the current situation. This is the master plan, where you can see there's a park like surrounding now around the lake. And here you can see people should be able to live in the near future around the lake, or enjoy park life, or campus sport. So this is more or less we can work further on the existing situation. If we are going to Lac Bataan, well, it was almost perfect lake. Only we had to stop dumping, and the discharges of uncontrolled water should be stopped. But then some basic treatment, and we can already think about fisheries. And that of course creates opportunities for park area, for recreation, fishery, etc. Again, you can see here the Lac Bataan Lake there. Here it's partially reclaimed and partly it will be still a lake, but this will be new green urban area. And you can here see some impressions how it would look like. And also we can exploit the good quality which is still present there. And then we come to Sabrat Lake, which is completely covered with a thick layer of oil. Also the sediments, we have a mud volcano with oil erupting from the subsoil, so no way we can restore it in the traditional ways. And here we came up with the idea to most part of the lake will be reclaimed, and then maybe there's some potential for urban area and also beautification as a park. And here we can see here most of the lake is disappeared. Of course, we have to take into account that we have to drain the area for future, but then it can look like this. A new urban area. So every lake has its own set of conditions, and that more or less influences the feasibility of remediation strategies, and we have to take it into account. And only we can assess this only if we have a good data quality. If we don't have data, we cannot make a strategy and can assess how it's possible. But both the project in India and in Azerbaijan, they are under big pressure of time. We have to be there in 2 or 3 years. We have to arrive to the new situation, and that's completely different with the situation which we had in the Netherlands, where we developed in 40 years our toolkit. But the good news is we have now filled our toolkit with all the techniques required, and we can help you to solve problems. And that was more or less my conclusions. And it's about also, I think, integrated cyclic approach. It's not anymore a process from here to there, but you have to do a few cycles to come to the approach. Because maybe you need, during the implementation of dredging, you will get new data which you can use to optimize your approach. Okay, thank you. And see you.